VISI CAD/CAM. TST Tooling Software Technology presents the VISI 2017 R2 CAM webinar. So what we'll be going through today is just like an online version of what we did in our in-house seminars that we had at various locations. Next time, if you get a chance when we do the rollouts next year, please come to the seminars. They're pretty informative, and we usually have a live demonstration of something. And this year was the Waveform machining. Please look for any announcements about that. And if you're watching on YouTube, please link, subscribe, and like the videos, and we'll be able to make more of them. So first up, we're going to go through some of the enhancements to the translators. So as always, we have some quality improvements and updating as other software updates. We have continued to make ours better. So some new capabilities: support writing WCS for IGES and STEP, as well as JT Open Import-Export libraries have been updated to 8.5.0.1. So let's take a look at some of the software installs. So our supported OSs, as you can see, are up on the screen. 64-bit only has been kind of a norm for a little while, so that should not be a surprise to too many people. CLS is automatically installed, and it will automatically update as well from the previous CLS if it's installed. It will make it a little easier when we're installing. So as always, we have the ability at the end of the install to install a password file, read release notes, update configurations and settings from previous release, or launch VISI. You can check these in the appropriate manner here. So you can also run it as an active utility as well, or at the end of the installation. Also, what you're going to see this year is a VISI launcher. Let's take a look at the update settings. Same menu that some of us are used to. Check what you want to update in the CFGs, and then direct with the 3 dots to your previous VISI path, and we can pull those settings forward. The previous releases, even before R1, are supported, and you can use those. If you drag and drop files, it can cause issues. That's where the CFG and the update settings are going to help out a lot. So please keep doing those. So what you're also going to see here as well on the installation are going to be some Vero Customer Improvement Program. It's a total voluntary program, does not access or collect any information about any non-Vero application, and does not collect data for any other purposes than future development. So it's a voluntary program. Like I said, you can click yes or no. What this is going to do is basically just analyze some of the commands we're using to help us develop different commands, or make us not split commands, or command consolidation. We want to make sure it's going to actually work, and that gives us the data to do that. So let's take a look at this VISI launcher that's going to be added here to your desktop. We'll have this VISI launcher. This is what it'll look like. You have a couple different areas here that we'll kind of go through. First area is going to be your product launch area. That's going to include your VISI team, Vero Tools Manager as well, and it can be accessed without VISI being open. That is the Vero Tools. There's going to be a utilities area and a custom area. Social media feed as well on the right. So let's take a look at what that's actually going to look like in this video here. So you're going to see on the desktop we have a VISI launch or launcher. Let's open that up. So what we'll see here is the layout that you'll see. VISI can be launched right from the icon here. also VISI Team can be launched as well. Team is a software for us to be able to work on multiple files by multiple different designers all at the same time, and then it combines those files back together. So there's a remote support button. This currently is going to be directed towards Vero UK. Please do not use that. We will direct that button to us. We are working on that, but at this time, it's going to significantly delay the response time, and it's going to be us responding, but it's going to take a little bit for them to wake up, find it, direct it towards us, and us to get back to you. So we also have the license manager, batch converter, migration tool as well, and the VISI NC editor. So we also have this custom area here. So let's take a look at adding an icon to that. It's a simple drag and drop. Maybe you got Part Explorer and you want to throw that in there, and maybe a starter file. It could also be maybe a VISI for you Cam guys, depending on what you're setting it up on. Right there, loads the file, and you're good. So let's take a look at the graphic management improvements that have been made. So 4K monitors are now fully supported, and that's not to say that they wouldn't work before for some of you guys, but you might have seen some inconsistencies in the graphics. So with that, there are going to be some revisions to the icons. Okay, you'll see a lot of them have been updated, and the reason being is when you go to make those on a 4K monitor, they become really pixelated. So they feature a higher DPI resolution. As well, with those updated icons, we have the ability now in System Options, and User Interface to affect the toolbar icon scale factor. Font scale factor, application scale factor can all be independently managed. Now, keep that in mind. If you start to get some crazy big icons, and or scale sizes, you're going to have slider bars that pop up to fit that on your monitor. You have to match at best to your monitor. You can't just blow them up and expect it to fit on the screen. We got to match it appropriately. So you can see the different scales here: 100, 200, 300, and I need glasses. So font scale factor as well, and application scale factor. So all those three. So there's also DPI operation scale factor that is in the status and general information. So let's keep going. Let's take a look at some of the new icons. Some of these are either updated or added to things that didn't have icons. So edit, extract group profile, move double elements, direct, ellipse. Under solid, we have the draft surface from a face, trim faces, automatic reverse surfaces, join, a couple others, modeling pattern, translation rotation mirror, analysis, model thickness. There's a couple of new ones there. Just adding to some that didn't have them. So let's take a look at some of the icon adjustment that we have been able to do. So this is one of those things that was put in as enhancements by some of you and other people around the world. So we have been able to get the ability to affect the graphic area layout. So some of you wanted to take out some things, put in some other commands. So we still have the default commands, but we're able to access through here an area to change those. So we'll go through that in a little video here in a second. Let's move on to the standard warning messages. So these are going to be a big thing that we gotta make sure we understand. Okay, so when we're doing a file new, file open, or file exit, we want to make sure that we understand what we're doing here. Previously, it was a delete all database. Are you sure? Yes or no? Now, what we'll see is a warning. Save changes, yes or no. So just make sure we are doing the appropriate thing for what we have going on. It's going to be a big one, just because sometimes we're in a rush and we're quickly going through that. Make sure you are doing the appropriate thing that you want. So let's take a look here at a little video, and it's going to bring us through some of the things we just talked about. First up is going to be the graphics area layout. So we have our stock layout that's there. We can also access that graphic area layout through an icon as well. So not only through those 3 bars in the corner, but we can access it through the icon as well. So our stock setup, we've got some of our views up there. We have a top, bottom, right, front, back. We can remove any of that we want. We can add in a few that we want as well. We have to direct it to where we want to go. And orthographic views added. You can change also the position as well. Say OK, and you can see the change there. There's no restart needed, no relaunching VISI. So on our graphics here, some of those you might use, some of them you might not. Often one we can take out is that facet mesh maybe. A lot of guys don't use that. So feel free to go in and change those. Again, we can access this area through the icon or through here and the 3 bars and going to the graphic area layout. So you can see here we changed up to get some things that we wanted there. So switch wireframe, get that toggle button there. There's that right hand menu you saw. Right hand menu is still, your fast context menu is still available. And there shows us just a little bit of functionality there. You can also take a look here. What we're using is a brush selection here. So that brush selection is going to allow you to, instead of selecting your normal points or elements, you're able to do a brush selection. See that? That line, and anything that's touching that line is going to be selected. So let's take a look at some of the R1 camera view. A little bit, obviously, this might be some rehashing for some of you. Some of you, if you're jumping from 2016 R2, this will be good for you guys to check out. So one of the big things is going to be the geometry management. So one that I am a fan of. I love it. It's way smoother and a little bit just friendlier overall. So pieces management update is not limited by the project. All pieces are available for machining. So in the past, when you had to Make sure you add it to the project first to be able to see it in the operation. No more of that. We can simply have it in the model manager and be able to select it. And even if we don't have it in the model manager, we can actually add it on the fly. So in addition, we have a separate meshing tolerance as well for each piece. The face groups has been dismissed. Now we still have face lists, and we can machine to them in certain operations and whatnot. But the whole idea of a face group having to be defined and then having a face list has been dismissed. It's now just a set of faces or face list separately. So also the quality factor is linked to the operation now. So adjusting that quality factor is going to affect the tolerance and the cordial, or the tolerance on that part. And the quality factor is going to scale that up, create more points, and scale it back down and compute the toolpath. So it's going to be a little bit new UI. Obviously the model manager is pretty much the same. You'll have face lists in there instead of the face groups and then lists. So that'll be easier, kind of saves us a step. New piece, stock, and obstacle selection. New face list selection. Groups are defined in an operation. And let's take a look at some of those changes here. So we can see we have a little bit of an example here with some different reference pieces, some face lists. So you can see the model manager is really pretty much unchanged. We still have our list, our stock, our obstacles. We still have the little lights to turn these on or off for visibility within the cam area. You can add a face list or add a whole face list for the piece. And we have a couple individual face lists there. So let's see, the project parameters page has changed. It's significantly reduced in size and just is overall a lot simpler. The project, though, can only have one piece, one stock, or one obstacle. If you try to add two, it will give you an error, invalid selection, wrong number of items. So we can only have one. That doesn't mean you can't use two pieces on one operation. Just in the project parameters, you can only have one. So let's take a look at adding an operation here. We'll select a tool. So here in this roughing spiral, we have our selected pieces here. So we have a reference piece, but we also have the ability to use a piece from our list, and we can use any combination of them. You can also adjust the name in here or the cordial tolerance. There's an X to remove, and there's an arrow once we select it below to bring it up as well. You can also double click and move it up to the area where we're going to use it. So we get that warning message to update the limits as always. We will have that same message if we add a reference stock as well. So we can either double click that or move it up with the blue arrow. You can also add after we adjust this cordial tolerance, I'll show you, we can add using that icon there if we want to add on the fly a piece of stock. So the operation geometric limits adjustment, we'll want to say yes if we want to adjust that, or no if we do not. Obstacle there. Same thing, same menu, real consistent as far as what you're going to see in the Obstacles, Stock, and Pieces menu. So let's adjust. We're going to adjust some of the parameters here. We can build something. Obviously, the organized mesh on the first operation that's going to be built for the file. Turn off some of these things, and the toolpath should be up for us real quick. There you go. And you can see, just based off the stock area, what we're going to cut. So let's add an operation to piece 2. Let's do a raster. Pick a tool. Notice no red marks on that, so all the cutting conditions are filled in on this tool crib. Saves a lot of time when we have those all filled in. So let's take a look using that face list though on piece 2 and or different face lists from the other pieces. Let's move that up. We are able with that face list to edit the properties. So we're going to define obviously what we're going to do with that face list. To be machined, protected, or ignored, and if there's any offset number as well. Same thing here. We'll adjust some step overs and step downs. And let's go back to that raster. And we're going to hit B for build using those hotkeys. And that should be up pretty quick for us. Let's take a look at that. There you go. We'll add another operation. So in the 5-axis or the ISO, we can use a combination of faceless and faces together. So select a tool and we'll go into that interface. For those of you who haven't seen this interface, this is what the ISO machining looks like. So we're mainly going to run off faces. And here you can see the same dialog, same management that's going to go on here. Select the faces on the fly there. There's our list. Say OK. You can also right click to confirm the box as well. You can use a face list or individual faces. Let's build that. Nice and fast. There you go. So let's move on here. Let's take a look at some of the stuff that we put in here for R1 for the 2D machining. You're going to see a new profile. It's a direct replacement for milling. Got some speed improvements, obstacle management improvements. The Toolpath is trying to look at the obstacles better and the pieces. There will be an automatic conversion of the old milling templates. You can see it here, shown here. This is what it'll look like. It'll be purple and require you to rebuild it. However, you can also right click and confirm and keep the toolpath you had. You do not actually have to. Now you're not going to be able to affect that toolpath, but if it is good, And maybe from a legacy program, you can right-click confirm and still use that old milling toolpath. So the profiling has improved reliability and cutter comp. We can see here that some of the cutter comp issues that were passed on to the post-processor with designating different points. Intelligent approach points as well. This is that toolpath conversion. From milling, you open it up and you'll see it purple. Applies to milling operations, and toolpath status changes to that not aligned. So profiling, the obstacle management improvements has some obviously better intelligent collision detecting and trimming, and we have even furthered that in R2. So advanced tool shape management, it's going to help drive these tools in, say, a complex pocket around some of these areas and produce the proper shape. So also some advanced corner management. This is available in the profiling. We'll take a look at all this as well as the rest area. So in here, you can see the not aligned status. Okay. You can see this is the old toolpath from the milling. When we right click here, you'll also see the confirm. See the confirm toolpath, you can actually select that. So let's take a look at the 4 diameter comp. And you can see when it's actually leading in this area for the diameter comp, it's actually colliding. See the red. So let's duplicate that toolpath, and we will take a look at some of what we have in here. This is the profiling menu, and let's take a look at the obstacles. We don't have any in there, we just have the piece in there. So let's let that rebuild, and we'll see what that does. So you can see that without actually adjusting anything, the toolpath has been altered there just by the rebuilding, and we have some better approach points. Much better approach points, going to do us a lot better of a cutting job. So you can see the milling strategy here. We currently didn't trim out for those obstacles very well. And now with the profiling, we have that ability in the engine to use that. It makes it a true 2.5D engine. So let's duplicate those. We'll see the difference here. So we can see the toolpath has been trimmed for those obstacles. Like I said, some of this has been even improved even more in R2. Let's take a look at that advanced corner management. So this is for some of the die guys. Not having to model in some of this can help eliminate some time for some of the design end of things, whereas you have the ability to do different things with these corners. So we'll kind of go through here and show the different ones. So that is the sharp corner management. Let's go in here to the properties and see the round for that outside corner. We'll open up this one, and again, properties for high speed. And this is twizzle. That twizzle looks pretty weird, but what that is going to do is help reset that ball screw on that machine and really create a good toolpath for you. We can put the high speed on. For those of you with some of the controls that a little bit better on the high speed, you can use that. They have all the different management options. Round. So let's take a look at this orange toolpath indicating a collision. So this one is on break radius. So what it's going to do, it's actually going to break that radius there so that we don't deal with that sharp corner. Eliminating maybe some benching, or the benching guys coming over and saying, hey, can we break these, make it a little easier to fit that. So let's take a look at some of the changes that we saw here. So starting from 2017 R1, you can see a change in behavior with some of the 2D using the negative allowance on a profiling operation. This behavior has been introduced to align the results from 2D profiling to coincide with the 3D operations. If you guys have run constant Z's standards or something like that to maybe interpolate a hole, you already know about this. It has been commonplace in the 3D for a long time. You're shifting the whole toolpath down if you're using that bottom allowance. The bottom allowance should not be used to drive the toolpath down any longer. What we want to use is the minimum feature Z minus. Okay, and in R2 this is going to act a little bit differently than what some of you have seen in the R1. It is going to allow you to do this through the minimum feature Z minus, even if it's not a blind or through feature, or a blind feature or through feature. With a blind feature, it wouldn't let you previously. Now we let you, you just have to confirm it. So moving on, we also have some advanced tool shape management. V2016 and previous, and V2017 R1. We can also see some improvement going to R2 as well. So let's take a look at some of the compass technology, because it's going to be a big one since some of the stuff changed with the milling to profiling, obviously. The CMPs have changed, so the setup form is all a little different. So what we want to do, instead of dragging and dropping those files, we want to run this conversion. Okay, it applies to convert template and template by folder. It has a new check compass rules. We can also have a fixed compass rules and a renewed CYT editor. Maintains the accurate conversion rather than dragging and dropping, which is not going to work for you guys. So let's make sure that we're doing this, especially if you're jumping from a previous, from R1. So we're going to browse a folder that we want to go to here. And you can see applying that converts that 2016 R2 and starts going through those CMPs. We can see we converted them, but not all were converted fully. It contains some errors, and some of the language and expressions need to be changed. So we can see there that this one wasn't. So we can right click, go to Fix Compass, and we can right click and edit, reset, set. Take that E out. Put the proper adjustment in there, and we can recheck that compass. So if you guys have any questions on the compass or need help with it, you can also either do that when for doing some update training for you, and or maybe on the web you can get a little help with that as well, through a GoToMeeting or something with our support team. So let's take a look at that 3D machining. So, updated engine. The waveform is officially released. That is going to be a step-down method within the roughing hybrid for you guys. Some of you guys have already been using this and loving it. This is partially what we showcased at the seminars in-house in a machine house. So look at some of the rest improvements as well. Rest roughing. Stock automatically used when previous operation is selected. Reduces the need to build that incremental stock. Builds correct stock for 3+2 operations, meaning you can actually reference other toolpaths in different cam setups, reducing the need to develop or make as many dynamic stocks. So let's take a look at that and some of the benefits we're going to see. So V2016 working based on the DIS stock management. So let's open up and set some things. Here we've got dynamic stock there. As you can see there. What we're going to do is we're going to set up a couple different things. So V27 is working based on previous op plus the automatic stock. So that dynamic stocking is going to be happening in the background, even when that reference operation is used. So adding that stock to that first operation initial is going to help out, and it actually helps those subsequent operations. So let's build some of these roughing hybrids and check them out. And we should see a very similar toolpath here by obviously having it set up just using the previous operations inside the parameters. So also in R1, some enhancements to the kinematics, some improved quality, improved collision checking, ability to measure some distances. We also have a new menu, shift plus right mouse, and some video capture for the machine simulator options. So let's get to that bread and butter here. For all the guys who are coming to the R2, this is what we're going to see as far as enhancements. We are going to see new pocketing. Note, we have pocketing classic here and pocketing. So we get the ability to still use that classic pocket, but this new pocketing is going to allow us to do the waveform. Okay, that's that full tricordial cut, full depth of cut, smaller step overs. We're trying to get to as close to that 40% of the tool as we can. Obviously, that's an optimal condition. Your harder materials are going to have to scale back from that. We also have a new remachining available and some better stock management for the operations. Including that, we also have a better island management. So let's take a look at that waveform. That full tricordial, full flute cut, peel milling, as some people call it. That waveform option is defaulted in a step over method. We also have an area where we can add some extra properties here, and you can see them here. Finishing pass, or lap of honor as some people call it. That micro lift height and a high feed on back passes. So it's going to have a tapered entry to it. You can kind of see this here. It's got kind of almost like a beehive, well, not quite a beehive, but just a tapered entry. Some smooth tangent toolpaths, as you can see here. And optimize arc output. So let's take a look using this example here. We're going to add an operation and go to pocketing. We're going to select our desired tool. Do you want to create a single one? Yes or no? Waveform is available as a step over method. You still have zigzag, you still have all those others. We have the properties here: high feed, cleanup, final pass, micro lift. It's going to really speed up these material removal rates for us. Okay, that roughing, get it all out, get it out of the way, and then come back in and maybe do that either final pass on some of those things that are not as crucial, or come back with a profiling to get those tolerances right in spec what we need. See here we helical down, full material and full depth, and now it starts. We're seeing a lot better times, obviously, with the removal rate when you have these set up. And it's going to really speed up our material removal rates for us. Just another tool in a shed. Doesn't have to be used every time, and it might not be appropriate every time to use that waveform in the pocketing. But what it is also going to help us do, not only the waveform, but in others, the pocketing strategy is going to help out with some of these open pockets here. So more optimized toolpaths on these features. So we're no longer feeding from the center and then moving out. We're going to change now, but it always starts from those open edges. It's going to greatly improve your tool life, and overall is just a better way to approach these features. Logical order of passes, and open edges can be treated in a closed parameter. So those open edges overlap. Instead of, I see guys sometimes be drawing edges out a little bit more and whatnot, and certainly sometimes you might want to do that when you have a specific case to control it, but most of the time this open edges overlap is going to do that for us. Most of the time it's going to give us what we need. Let's take a look at that in an example here. 2017 R1 and previous. You can see we have a decent tool path, not too bad, but we have some areas here that we really don't need and kind of overlaps here. We can see we have our toolpath in our path lab. Let's take a look at what we got from the new pocketing. Now we can see it's just a little bit more efficient toolpath with those entries and exits. Back to a rapid, boom, go. Into the material, done. Back to its next pass, or level, and so on. So in here, we can duplicate here for this pocketing here. It's a spiral auto. Let's take a look at the open edges overlap. This is what we should be using instead of extending those edges. This should be what we use here. It could be treated as it's closed. So that pocketing strategy is now going to help out in areas where the tool shape can be influenced by the selected solid piece to avoid collisions. So also with the pocketing strategy, we can machine from a stock model. If defined in the material only, produces passes where necessary. So design changes, that's a key improvement there. So it provides an optimized toolpath, obviously, reducing lifts and only cutting where we need to. Also, a feature of the new pocketing is going to be intermediate slices. What that's going to be doing is kind of a full flute effect, and then come back with some passes to basically create, basically a semi-finish all in the same toolpath, a roughing and a semi all in one. Let's take a look at this in the example that we had it shown there. So with this piece, kind of a bathtub type effect, we can shut off our stock so it's a little easier to look at. And we have a complex pocket. Add operation. You see we have our pocketing. Say apply for our toolpath. We're going to use the spiral auto. We have a step over. We have our step down. And some intermediate slices. You can affect your step down or retract step downs or step ups as I call them. You can see we get a nice big helix in there. So with that spiral auto, let's look in the Path Lab at it. Go to a wireframe so we can see through this thing. You see we helix down to that level, do our full flute of cut. So not only can these be used with a solid carbide end mill, but you can use these with the inserted mills as long as you're following the recommended depth of cut. And intermediate slices here help give you that contour. So that retract step down is going to help give you that contour and shape there. So let's take a look at the Cam Profile Island Management. Cam Profile attributes for closed profiles. Islands are automatically recognized. Quick and easy creation and editing. Let's take a look at that. In the VISI 2016, we have an example that was set up using VISI 2017 R2. Hit that Cam Navigator open. So let's take a look at the pocket here. We have a couple bosses in there, and even one that is only partially intersected. So in VISI 2016, we had a specific process here. We had to open the feature geometry here and pick our islands. We could say OK and add. So now those are included there as islands. Now you can add an operation. Accept our project, add our tool, all the normal stuff. Island allowance. We can define that island allowance there. We'll say OK. So you can see it stayed around the islands we selected, but not that partially intersecting profile. So since it's only partially intersecting, we're going to have trouble. Let's look at our operation here. Turn that off. So in 2017, we have the ability for profile cam attributes on open and closed geometry. So in pocketing, let's open one up. We'll select the same tool there. This gives the user freedom and easy creation and use of the islands. It automatically saw those islands there. No adding go into edit geometry or any of that. So even partial intersecting geometry is easily added as an island. Okay, so keep that in mind when we have geometry that's on top of each other, or profiles with cam attributes that are on top of each other. Do keep that in mind, that the island management is going to kind of take effect. So let's take a look at the 2.5 axis cam and profiling, or pocketing and profiling strategies. For R2, we have obviously even better advanced tool shape management. So it's constantly getting better on some of this, especially with those complex pockets, for some safer toolpath for that kind of cut here. So let's take a look at what that actually means here on this example. Got a complex pocket here. Kind of a varying radius shape here down the side. So with VISI 2016, we'll take a look at what this looks like here. And then 2017, we'll see how that is being generated as well. So let's open up that path lab. You can use a hotkey for that of T while you have that path highlighted. So if we go to move on point here, we can see got some red areas here where the tool starts violating that complex pocket. The tool's getting driven down there, and the tool shape management isn't allowing to see that as it needs to. We can even use a toolpath checker. And we can further verify to see if that's going to violate. And we can see here, 4 collisions, points have been created. So, 2017, profiling. Let's take a look at that path lab, that move on point. We can also see the points here. And now back to the move on point. You can see how that's starting to drive out quite a bit further than the previous one. Keeping that edge there, and then tangentially moving off as it needs to, as it should be. Let's run that same check. Toolpath checker, select our piece. We can also double click that piece as well. We've got a few options for that as well. No collisions found. Awesome. So let's take a look at remachining. So remachining has been improved here. Has the same characteristics as pocketing, based on reference operations as well. And uncut stock obviously can be shared between 2 and 3D ops, which is awesome. Updated 3D cam engine to improve the roughing and remachine strategy. Quality improvement on waveform roughing. A number of important fixes on all strategies. Fixing on data validation input as well. So let's take a look at that enhanced roughing and remachine. So what you're going to see is a way better dynamic stock that's going to be created. a lot of these little areas could cause us Toolpath to kind of go and dance in an area where it might have not been so desired. So it's obviously a more reliable Toolpath because of that, a little bit better quality output, and improved residual stock. Let's take a look at some of that. So we've got a piece here. We've got an initial stock and some of those roughing remachines already built. So let's turn that off so that we can see, obviously, start from a full piece here. We'll go to the old roughing, the old dynamic stock engine. Pretty tessellated and got some triangles there. The way it's stitching that together now using a little bit different model for that dynamic stock, it's going to create some much better results. But you can see here, this is kind of what we're used to, but we can improve on it as always. Let's turn that off and turn on the roughing spiral, and let's look at the new dynamic incremental stock. So that's not only going to help your Toolpath, but help you guys visually if you're looking at it as well. Remember, there's tolerances on that, so depending on what using as a tolerance is how long it's going to take to build and calculate all that. So the auto smoothing options in roughing, the calculation engine by default applies a small smoothing rad on all sharp corners. R2 has the ability to enable and disable the automatic smoothing, preventing unwanted results. Useful with smaller geometry where the tool and cavity are the same size. And some more automatic smoothing. So let's take a look real quick and check out. Some of you might have ran into this already, others have not. We can see if we go to a wireframe, we're not quite going down with that bottom of the depth quite where we need to. If we go to the Path Lab, move tool on point, and then you can see we stop far shorter than where we need to go, or far too soon. Obviously, we check our toolpaths before we send to the machine, so we would have caught this, but let's go in and adjust that. I'll duplicate it first so we can see the difference. Open that up, properties, and you can see the automatic smoothing option here now. So let's uncheck that, say OK, and build. So that's also something you could set in a template or a snapshot, as well as defaulting it as well. That Path Lab, same thing, move tool on point. And if we hit 3 to show our tool, we can see we're getting a pretty good result now. And if we run it through, adjust the speed, looks pretty good. Also, with some of the 3D machining, you're going to see a shank clearance. Not only you have the holder clearance, but you also have the shank clearance. There's a new option in 3-axis, some of the 3-axis strategies, control over holder and shank clearance. It's not available on any of the 3-axis standard operations, only the 3-axis strategies. Let's take a look at some of those, just to kind of show you and give you an idea of how that works. Pretty simple concept, but we'll take you through a quick little overview here. Let's open up that Waterline Evo, which is a 3-axis strategy. You can see the toolpath starts stepping away. Once again, toolpath, We're playing it, and we also have our tool holder and our tool on, which is 3 and 4 on your keyboards. Can be seen down here as well. Tool 3 and 4. So let's open up the properties of that waterline Evo. We'll first duplicate it so that we can see the difference when we adjust some things. So under tool holder parameters, you'll see the holder clearance, shank, and holder. You can see a little diagram obviously updates. We'll build that operation. Shouldn't take too long here. We'll get rid of that guy so we can see a little bit better. So with that on, we can include the shank there and further fully trim that toolpath like it should be. So also to note on some of the quality factor, adjusting that's going to scale up that toolpath, create some more points and everything. It's also going to obviously increase the size of your toolpath. Okay, some machines love some more points, so you can bump that quality factor up and can help out there. So enhance data validations. So we've always obviously trying to improve some of these. System can intercept unsupported values, stops the calculation, reports more information in a log window, and just helps prevent that toolpath from sitting there and then erroring out finally at the end. Trying to do some more checks to make that a little faster. The log window is created. You have to have built the toolpath to have the log window. So when you're looking at a different file or something, just make sure you have, if you don't see the log window, you need to build that toolpath to have it. So enhancement of the parameters validation on 3-axis as well. Additional checks and interception of possible unsupported settings. A safer system and time saved on the toolpath calculation overall, not having to let it error out the end, rather do that check before. So let's take a look at some of the quick example here we have for a planar operation. We'll hit build, and it has failed. So let's look at that log window. So in tip diameter invalid, 0.8 must be greater than or equal to 1.2. So in here we'll duplicate this and we'll make an adjustment. We can simply change the tool size and build that toolpath. And now we have some toolpath there. Let's duplicate that again. So we can change the quality factor to overcome the tool issue as well. Quality factor increases the accuracy of the calculation. If we raise the value of the accuracy greater, you can see that. So we'll build that toolpath. So let's take a look at another portion for machining. It's going to be the electrode machining. It's going to be a new module. Links with the electrode manager, pulls the data from the electrode manager, and automates the electrode machining. The electrode manager, we're defining everything we need to for a machining process, so this kind of just automates and takes away some of that unneeded step and saves time, obviously reducing errors too. And in this type of industry, if we can reduce some errors, definitely a good thing. So automates those parameters, that cam piece definition, stock, and obstacle all get transferred over. That milling project creation, all that stuff goes over. Executes a predefined operation template as well. So obviously, generally, we are going to rough those and maybe semi them all the same. Maybe some of the real intricate electrodes, you might do some additional steps, but primarily those first steps are going to be what we can accomplish with a template. So some definable settings as well are going to be in here as included. A customizable project name, a milling specific machine that we're going to, and a tool crypt to use. We have a customizable piece material, minimum Z limit for the predefined, for predefinition, and a template folder as well. Specific piece mesh tolerance, and customizable reference origin. So, kind of get you an idea, we're going from the EDM or electrode manager, for where we're defining everything, through to the electrode machining command. So that workflow is just going to help us create that project quicker and get those templates running even faster. Less clicks, less open the door for some human error. So let's take a look at the electrode drop down here and the electrode manager, where we have set up some electrodes, 1, 2, and 5. And you can see here we have the electrodes and the holders. So if we right click, the electrode machining will be present. From this dialog, it's possible to control, edit the most important things necessary, so that minimum Z limit there, all from the same dialog. We could snap to a point, certainly. We could do the math inside the box. We could measure using the measuring commands on the left here. Remember, in any of the dialog boxes in VISI, you can use that. You can have a specific origin to be used as a reference. You can offset the Z, Y, X, all that. All from that one dialog. You can define the stock dimensions, stock model that will then be used by the cam site. And offset an X and Y or Z. Let's say you want to offset that, you can do that as well. The color and transparency there can be affected. So, or a specific setting for a cam, like the name, very important for the electrode machining process. So this is just gonna make us faster in doing this. So we can load a template, specific template files. You can have them really specific or really generic. Those template files are gonna make you faster. Piece, stock, and obstacle are automatically created by the electrode machining command and added to the project. So we can take some of these predefined operations and start building them. We have a roughing spiral, steep and shallow. So predefined minimum Z is used by the operation, as you see here in the steep and shallow with the minimum Z range. Let's go into the properties. Project name is automatically defined. Can include your job number and all your relevant information. And project reference work plane is automatically defined there. The piece material is automatically defined as well. Let's look at some of those settings. So in the electrode settings here, we have electrode machine settings, and this is where we can affect a lot of this stuff. We can, for example, pull relevant information from this file. Roughing type. We can start building what we want that layout to look like. Width times depth. Give us all our information that we want to see. So we can see the change that would result in that. Basically like a compass for the electrode side. So we have stock materials that can be set as well, and associations. And we can assign those as necessary. That list is going to be driven off of the Vero Tools Manager, obviously. So let's take a look at some of the other things here. So for the 5-axis, we have an updated library, updated kinematics to include some of the shortest path simulations and quality improvements for that, and some automatic quality improvement here. So you can see in R1 and previous, as we play this and it starts coming in here, kinematics, if we speed that up, our kinematics is not going to appropriately simulate what the machine would do here. So in here we start moving, and in this position the simulator reports a collision between 0 and 359, and the limits are set to 0 and 360 for the machine. So if we keep playing that, it's going to start colliding there. You can see on the C-axis rotation, and we would have a gouge reported. So looking in the details, the simulator unwinds the C-axis rotating from 0 to 500 all the way to 359. So obviously it does it in a mathematical way. and it unwinds. And continues on. So it's obviously going to report that gouge there. So in 2017 R2, if we go and open up properties, we now have the ability to do the shortest path. It allows the controller to have it simulate the rotating axis unwinding. So now if we use that, go to our kinematics, we can use that K for a quick key as well. Don't forget about those quick keys. And we go through 345 as far as C-axis, keep going, keep going. And it starts unwinding itself. So we can properly simulate that with the shortest way there. Simulation completed without any warning. So for the R2 in the wire, we're going to see some updated wire engine to provide some improved functionality and number of fixes, some post fixes and improvements. Not much on the wire. So I want to thank you guys for taking some time to go through here for the 2017 R1 and the R2 CAM webinar. So here, please remember to like and subscribe if you're watching through the YouTube channel. If you have any questions or want to do some update training or help with installs, please let's give us a call at 248-922-9293 and we can set you up with that. Thank you. Have a good day.